Okay, so this year the fifth graders have a standard that requires them multiplying using standard algorithm. The good thing about that is that this is the way we were taught when we were kids, so much of this isn't you learning a whole new way, it's just refreshing your memory on how. So today we are going to be multiplying using standard algorithm. Most of the students are feeling pretty good about this, but just in case they need a refresher, we need there's two vocabulary words that probably need to be focused on. The first is a factor. A factor are the numbers being multiplied together, like 2 times 3. Those are two factors. The 2 and the 3 would be a factor. And then the other vocabulary word would be a product. Product is simply the answer to a multiplication question. Okay, so in the number 4,276 times 23, this is one factor, and 23 is the other factor. When we multiply our 3 through, we're going to get a partial product. It's a partial answer because it's only the answer of multiplying the 3. And then when we multiply this 2 through, it'll be our other partial product. So this is when we multiply our 3 through, and this will be when we multiply our 2 through. The first thing we're going to do is distribute our 3, and your child is going to want to make sure they start in the ones place. The 3 is going to get distributed. 3 to the 6, 3 to the 7, 3 to the 2, and 3 to the 4. So 3 times 6 is 18. Carry the 1. 3 times 7 is 21, plus 1 is 22. 3 times 2 is 6, plus 2 is 8. And 3 times 4 is 12. I don't need to carry the 1 and the 12 because there's nothing left to multiply by, so I just bring that down. Now because this 2 is in the tens place, we know we're going to have a 0 here to hold the place value of the 1. Some kids like to draw a smiley face. Some kids put an X in the middle, as long as they understand that it's a 0. And then we're going to distribute our 2 through. 2 to the 6, 2 to the 7, 2 to the 2, and then 2 to the 4. Please make sure your child remembers that it's to the ones place first. So 2 times 6 is 12. Carry our 1. 2 times 7 is 14, plus 1 is 15. 2 times 2 is 4, plus 1 is 5. And 2 times 4 is 8. So we've got our partial product when we distributed our 3, our partial product when we distributed our 2, and now we can add it up for our final product. And the final product is 93,348. Some kids were asking me earlier today what happens when it's, for example, a 3-digit times a 3-digit. So let's say we had 273 times 123. We're going to distribute our 3 first. 3 times 3 is 9. 3 times 7 is 21. 3 times 2 is 6, plus 2 is 8. We're multiplying by our tens, so we're going to hold our tens place with a 0. Distribute our 2. 2 times 3 is 6. 2 times 7 is 14. Carry our 1. 2 times 2 is 4, plus 1 is 5. Now, because we are in a hundreds place, when we multiply by hundreds, we're going to have 2 place value holders. So they should see a pattern. Now we can distribute our 1. 1 times 3 is 3. 1 times 7 is 7. And 1 times 2 is 2. Then we add them up. 15. And that's it. So we're going to put division along with this video as well. Last year, your child learned division using what's called partial quotient. Sometimes the kids forget, and even as adults we forget, that division is simply dividing a total into equal groups. So if I have a total of 6,729, and I'm dividing them into groups that have 64 in each, partial quotient looks like this. It's very much like what we normally do. It just looks a little bit different. So my first thing the kids are going to do is they're going to say, how many times can I take 64 out without going over? If I can take it out 100 times, 64 times 100. So I'm going to do 64 times 100, which is 6,400. So this is 64 being taken out 100 times. So now the most I can take 64 out would be, I know 6 times 5 is 30. So I'm going to try 5. 5 times 4 is 20. 5 times 6 is 30 plus 2 is 32. I'm going to take my 5 groups of 64 out, and I'm left with 9 as a remainder. So that's that. Now, some kids really wanted to learn standard algorithm. Standard algorithm is the way we were taught. Let's use the same number. 6,729 divided by 64. So we're still doing the same practice. How many 64s will come out of this number? How many 64s will come out of 6? None. So remove no groups. How many 64s will come out of 67? 1. Take out my 1 group. Notice how I'm lining everything up. How many 64s will come out of 32? None. Many kids get confused and they think they are done. No, they still have to take their 0 groups out. And how many 64s can we take out of 329? 5 times 4 is 20. 5 times 6 is 30, plus the 2 is 32. Take out the 5 groups, and it leaves me with 6. And that is standard algorithm. Let me know if you have any questions.